All right, final category of reactions is going to be your double displacement reactions. These are similar to single displacement, all right, but you will soon see how they are different. And again, you should be able to identify these and balance them. So double displacement has two compounds, all right, so these are both ionic compounds. All right, and what happens is the metals displace each other. All right, you always write the metal element first, so you can see A and C switch spots. Now C is attached to B and A is attached to D. All right, so you start with two ionic compounds and then their metals switch to form two more ionic compounds. So see if you can identify in this first one. Give it a shot. See if you can pick out which one is your double displacement reaction. And again, your basic formula is this. All right. Similar to the single displacement ones, I do need two reactants and two products, so synthesis and decomposition reactions can get crossed out right away. And then when you run into this situation, you've got to look, all right, where do I see two ionic compounds as my reactants, two ionic compounds as my products, and the only difference is that their metals are flopped. All right, so I've got copper chloride, sodium hydroxide, which becomes sodium chloride and copper hydroxide. So that first one, A, is your double displacement reaction. What is B? Again, you've got a hydrocarbon reacting with oxygen, making carbon dioxide and water. That's another combustion reaction. So, pause the video if you need some more time, but try the second set. Which one is the double displacement reaction? Hopefully you said D, because otherwise you have a decomposition, a synthesis, and then a combustion reaction, leaving D being the only one that would be a double displacement. These tend to be a little bit trickier on the balancing side. So let's get our chart set up here. I've got 4 things I have to keep track of. All right, so magnesium, phosphorus, silver, and chlorine. I'm going to do that in the same order over here. All right. How many magnesiums are there in my reactants? There's 3. 1, 2, 3. 2 phosphorus, 1 silver, 1 chlorine. And my products, all right, I've got 1 magnesium, 1 phosphorus, 3 silvers, and 2 chlorines. All right, so at this point in time, there is nothing that matches up. So just choose one to start fixing. Nothing shows up in more than one place, like with combustion where we want to do oxygen last. Everything shows up once in the reactants and once in the product, so you can choose whichever one seems easiest for you to figure out. I'm just gonna go with magnesium because that's what I see first. So I've got 3 here, 1 here. So that means I want to multiply this 1 by 3 to get it up to 3. So I'm going to put a 3 here. All right, so that's going to give me 3 magnesiums, but I also have to multiply that by the 2 of chlorines, so that's going to up me to 6 chlorines. 3 times 2 is 6. All right, magnesium's balanced. Let's look at phosphorus next. All right, I've got 2 here, got 1 here. So for me, I'm gonna put a 2 out front here. That will double my phosphorus, but that's also going to double my silvers, so now I have 6 silvers. So those are balanced. So now let's go to fixing silver. So I've got 1 here, 6 over here. So I want to multiply that 1 by 6. So that's going to give me 2, 3, 4, 5, 6. But that's also going to multiply by my chlorine, so it's going to give me 6 there. So hopefully you came to that same conclusion when you did it, of 1 magnesium phosphide, 6 silver chlorides makes 2 silver phosphides, and 3 magnesium chlorides. One other thing you want to recognize, because sometimes this one gets missed as far as still being a neutralization or a double displacement reaction, is a neutralization reaction. So this is something that involves an acid and a base combining together. All right, so this still matches the double displacement format. It's just it does involve one of the compounds not being ionic. All right, so you can see again, you've got sodium and hydrogen, the first thing in the compound switching spots. So that you have sodium chloride, and then HOH just gets rewritten as H2O. Alright, so neutralization reaction is also considered a double displacement reaction, and it's what makes something a neutralization reaction is when you combine an acid and a base to make a salt and water. So jot down some notes about that so that you'll remember this as an example, and you should be solid for any test or quiz questions you see related to it.